Alright, so sorry that it took so long, girls, for me to get this up for you, but here it is. I'm going to help you with some of the equations from our labs from last Saturday that we met. So for the first lab, we put the solid metals into some solutions and watch whether they react. We're going to call those the redox. Let's see, so redox equations for that lab. And for the first question, I'm going to give you the first one. So we observed copper as a solid, and it was left in a zinc nitrate solution, and that was aqueous, which means it's a salt dissolved in water, and that combined, and these two cations swapped, so it's called a double replacement. So now we have copper nitrate, that's aqueous, this means it's a liquid, and then we have our zinc solid. So that is going to be a balanced equation for a reaction that we observed. So that's one. So do that for every reaction that you observe between a metal and the ion solution. And for number 5, it's asking for about balanced half reactions for the reduction. So let's take the same example, and zinc was reduced. So if we were to just focus on zinc, it was connected with nitrate, and then it became a solid. So that means that it gained electrons. That's what reducing or reduction means in chemistry. So we can single zinc out. Sorry, zinc. And it started as an aqueous solution. We're going to write a 2+, showing that it had a positive charge if it was an ion all by itself. And then zinc on the other side of the equation becomes a solid. So that would be it for our half reaction, just showing the zinc had a positive 2 charge because it was attached to nitrate, and then it turned into a solid. So it went from a positive 2 charge to a neutral charge, so it gained electrons and was reduced. So do that for each reaction. Take whatever was connected to an aqueous solution that became a solid, and just write it as simple as that. Alright, and for the second lab, disturbing equilibrium, I'm just going to abbreviate that. For number 1, it asks for a balanced equation, and so this is going to be it for our potassium nitrate. It's aqueous, so it's liquid, and we're going to write our equilibrium arrows, and potassium nitrate solid. So this is all you have to do for the balanced equation. Show that it was a liquid. As it cooled, that crystal formed and became a solid. And this shows that depending on temperature, it can go back and forth to maintain equilibrium. And finally, for number 5 on this same lab, the balanced equation is iron chloride plus potassium thiocyanate, and those are going back and forth, and then we end up with iron thiocyanate and potassium chloride. Oh no, my pen died. Alright. Iron thiocyanate and potassium chloride. So that's going to be your balanced equation for number 5 on disturbing equilibrium. And it asks a few questions about Le Chatelier's principle, and it basically summarizes that the reaction will go whichever way it needs to maintain its stability. So if you add more iron chloride, it's going to increase the iron thiocyanate ions. Try and maintain that balance. So it doesn't want too much of anything on one side. So if you add some iron over here, it's going to convert some into iron thiocyanate. Hopefully that helps with some of the equations and understanding the labs. If you have any questions, please feel free to email me or let me know through Alicia. And look forward to seeing you next Saturday. All right.